Okay, guys, in section 12.4, we're going to look at volumes of prisms and cylinders now. Okay? Now, volume is the space that a figure occupies, and Cavalier's principle is the other thing we're going to look at. Okay? Now, Cavalier's principle is if two space figures have the same height and the same cross-sectional area at every level, then they have the same volume. Okay, so we're going to look at that a little bit today. Finding the volume of a prism. A prism is two congruent parallel bases. Sides are rectangles, okay? And the volume equals area of the base times the height. So make sure you write that down and have that in the list of equations you should be writing down. Okay, so the height is obviously the height of the prism. The area of the base is whatever the base is and the area. So you'll probably have to do a length times width to get the base. Okay? So if it's a triangle, if it's a triangular prism, then obviously the area of the base will be 1/2 base times height because that's the area of a triangle. And if it's a polygon, it'll be 1/2 the apothem times the perimeter. Alright, so let's look at this. Now the box shown is 5 units long, 3 units wide, and 4 units high. How many unit cubes will fit in the box? What is the volume of the box? So again, we have to do volume equals the area of the base times the height. So the area of the base would be 5 times 3, which is 15, times 4, because that's the height. So it would be 60 units. Okay? So again, we have 3 times 5, so we have 15 times 10, so we have 150. Okay? So let's find the volume of the following. I have my area of my base times my height. Okay, so I need to figure out the area of that triangle. I know that the bottom part of the triangle is 20, and the hypotenuse is 29. So I can use Pythagorean theorem to find the height of that triangle. Okay, and then that way I can do 1/2 base times height. So I'm going to start with 1/2. The base is 20 of the triangle. I need to figure out the height. Okay, so I'm going to use a squared plus b squared equals c squared, where b is 20 and c is 29. So if you do that out, you'd find b is 21. Okay, or a is 21, excuse me. So you fill that in for the height of the triangle. So you have 1/2 the base times the height of the triangle, which is the area of the base, times the height of the whole prism, which would be 40. Okay? So you should have 210 times 40, or 8,400 meters cubed. Got it? Alright, so another prism. So again, we have to figure out the area of the base and multiply the height. So I got to figure out the area of that triangle. Now, I know that I'm going to have to use 1/2 base times height because it's a triangle. And to do this, I know the base is going to be 8, and I got to figure out what the height of that triangle is. So I know that the half that base, which is right here, is 4, because if this whole thing is 8, then half of it's 4. If I draw a straight line up, that's the height. And I know that since this and this are congruent, I know this side's 8. So over here I have 4 squared plus 8 squared equals 8 squared. Okay? So you can do the Pythagorean theorem, or you can use SOHCAHTOA to figure out the height. And you'll find the height is 6.9. So we do 1/2 the base, which is 8, times the height, which is 6.9, and then multiply it by the height of the prism. Okay? So you would finish with 277. Now, Bonaventura Cavalieri, if he was born in 1598, died in 1647, he came up with basically what we know as volume. To see how it can be applied, consider the solids in the next slide. All three have cross sections with equal areas, and all three have equal heights. All right. So by Cavalier's principle, it follows that each solid has the same volume. So if I look at all of these solids, if all of their cross sections have the same amount and are the same area, and they're all the same height, then all of these have the same amount of volume. Okay? So let's look at the volume of a cylinder. Again, the volume equals base times the height. Volume's easy for these, for the prism and cylinder, because they're the same thing. So I'm going to have to find the area of the base, and of a cylinder, it's always going to be a circle, so that's pi r squared. And that will give me the area of the base. And then I just multiply it by however high it is. Okay? So, let's look at this one. I know that 16 is the diameter, so radius would be 8. So to figure out my area of my base, I would have to do pi times 8 squared, or 64 pi. and then multiply it by my height, which is 9. Okay? So again, pi r squared, or 64 pi times 9. So I would have 576 pi, and then I would have 1809.6 for the volume of this right cylinder. Now, what if I put a couple together? All right, find the volume of the following composite figure. I know that the area of this prism, okay, is going to be 12 times 4, which will be 48 times 11, because that's the area of the base times the height. So I have 48 times 11 for that. I know the diameter of my circle is going to be 12, so the radius is 6. So if I do pi r squared, that would give me the area of the entire circle, but notice this is only half of a circle. Okay, so I would have to divide it by 2 and then add the two areas, or add the two volumes together. Okay, so I would have pi r squared times the height, which is 452, and then I have to divide it by 2 again because it's only half a cylinder. And then the volume of the prism is base times height, which would be 11 times 12, and then times 4. Alright, it's 528. I put those together, and my final volume will be 754. Okay? So, hopefully you guys understand this. Pretty easy. You just have to know how to figure out the volume of the area of the bottom, and then multiply it by the height for both of these. Okay? So here's your homework, page 850, 1, 2, 10 through 13, and 16 through 18, and then you can move on to the next video.